So hello everyone, welcome back to another video, and today we are going to see the solutions for weekly contest 374. And I was able to solve first two questions, but I also solved third, so we will see solutions for first three questions. So first question is pretty basic implementation question. So we are given an array and we have to find all the peaks in the given array. So a peak is defined as an element which is strictly greater than its neighboring element. So ai must be greater than ai minus 1 and also greater than a of I plus 1. So this is the only condition we have to check, and if it's satisfied, we have to push it into an answer array and we have to return that vector or array. So as you can see here, I am iterating from 1 to n minus 1 because it is given that first and last element cannot be a peak. So for each element from index from 1 to n minus 1, I am checking this condition and just pushing it if the condition is satisfied, and finally returning that vector. So this was pretty basic implementation based first question. So next question is minimum number of coins to be added. In this question we are given an array which is named as coins and also given an integer target, and we are also given a statement about obtainable. So if an integer x is obtainable if there exists a subsequence of coins that sums up to x exactly x. So we have to make all the integers from 1 to a target obtainable by adding some minimum number of coins of any value in the array. Let's see an example. For as you can see here, one in the array 114, 1 is already obtainable because I can just add 1. 5 is also obtainable because 1 plus 4 can be equal to 5. 11 is also obtainable because 1 plus 10 equal to 11, and similarly 14 is also obtainable. But numbers like 2, 3, 5, 6 are not obtainable. So we have to add some elements in this array so that all the numbers from 1 to target, which is 19, should be obtainable. For example, here we add 2 and 8. So 1 is also obtainable, 2 is also obtainable, 2 plus 1 3 is also obtainable, 4 is also obtainable. Similarly 4 plus 1 is 5, 4 plus 2 is 6, 4 plus 2 plus 1 equal to 7, then 8, then 8 plus 1 9, and up to 19 all are obtainable. And as you can see here, if I just add 2, all the elements from 1 to 19 are obtainable, and here also 3 elements needs to be added, which are 4, 8, 16. Now let's see its solution. So let's go to most basic condition. Let's say I have an array of length and 1 and only element present is 1. Now I have to make target. Let's say target is given as 3. So what should I add here? So all the elements from 1 to 3 are obtainable. The answer is pretty simple, that is 2, because 1 is also obtainable, 2 is also obtainable, 1 plus 2 3 is also obtainable. So what is this 3 and the total sum? The target and total sum till here is equal. Now let's say I increase target to 7, let's say. Now what should be the answer? What should be a number I add so that all the elements from 1 to 7 becomes obtainable? If you see that observation, it is 4. Now as 1 is also obtainable, 2, 3, then 4 is also obtainable, 4 plus 1 5 is also obtainable, 4 plus 2 6 is also obtainable, and 4 plus 2 plus 1 7 is also obtainable. Now if I increase, let's say 7 to 10, now as target has become 10, what should I add here? The answer can be 3 also, or any element greater than or 3. So answer here is 3. So why is answer 3? Because it is the difference between target and current sum. So it can be proven that, let's say I have an array of length L, and the total sum of that is let's say sum. So if the array of length L can obtain all the elements from uh, 1 to sum, so if I add an extra element, or let's say its value is x, so the length of new array will become L plus 1, and it will represent all the values from 1 to sum plus x. And again, if I say I add uh, one more element of size y, the next all the values from 1 to sum plus x plus y will become obtainable. So this was the key observation in this question, and this the proof of it is this will you will understand by understanding the base case, that is 1 and 1, and try multiple cases by adding a number, and it by adding a number, and try to find the observation by yourself. So let's see the solution for this. So first of all, I sort the array, and for each integer I from 1 to target, I am calculating the total sum for which a of j means the index in current index in the array. If it is less than I will just add that ej into sum, and when this while loop ends, if the current sum is greater than I. So for example here, if the sum is already greater than uh, uh, the I, so let's see, for let's say we have this array, and the sum of this element is 3. Now as it is 3, I can say that all the elements from 1 to 3 are obtainable. So if sum is greater than equal to I is also obtainable. So we don't have to do anything if I is obtainable. But if it is not obtainable, we have to add increment counter and add an element which is equal to 2 into sum plus 1, which is equal to sum plus 1. So for that we can find this observation here. So let's say I have elements 1 1 1, then I add 4, sum becomes 7, then I add 8, the uh, sum becomes 15, and then I add 16. So at each step I am adding sum plus 1 value to the array, and what it does, it increases the possibility of all the elements which can be obtainable. So for example, after 1 2, if I add 4, all the elements from uh, 1 to 7 becomes obtainable, because the sum increases, the number total values increases by current sum plus 1. So current sum was 3, and the all values obtainable was 3, but increased by 4 after adding the integer 4. So it is the most optimal addition. So that's why I'm adding sum plus 1 to the array. So I don't have to add it to the vector, I can just add it to the total sum total sum value, and I will just return the number of elements at the end. So let's move on to third question. So this question was tougher than normal seeds on Leetcode. So let's start with the question. So we are given a string or named word and integer k. So we have to find number of substrings such that in each substring these two conditions are satisfied. The first condition is each character in S occurs exactly k times. So the number of occurrence of each character should be k if it occurs at least once in substring S, and also the difference between two adjacent characters, that is any two adjacent characters, let's consider them as C1 and C2. The absolute difference in their position in the alphabet is at most 2. So that means the adjacent characters can be AB, AC, or BA, CA, but AD cannot be there because the absolute difference between these positions of these two characters in an alphabetical order is 3, because A, B, C, D 1 and 4, 4 minus 1 equal to 3. So this will not satisfy the substring, but this two will. So we have to find all the substring number of such substrings in the string word. So for solving this question, let's whenever a question comes into a contest where I have to find substring, first everyone first will try to think according to a two-pointer approach. So for example, let's consider this string. Now here you cannot write two-pointer directly. For let's say I started from A, I will iterate through all the substrings till C. I have to iterate to all the elements till C, because if I just iterate over A and it will fail at, let's say it fails at it will basically fail at second A only, because all the substrings, the number of occurrence of A are 2 and we are required 3, so it will break at this only. So it will not count all the substrings like A also satisfies the condition, B, this also satisfies the condition, and this also satisfies the condition. But if we do not break, it will become a solution of n square. So we also don't want that. So we cannot use two pointer directly, we have to use some other logic. Now other thing can be is to try to find a solution of 26 into n. So 26 means 26 basically means number of characters in an number of unique characters in a string which are possible. So in every string there can be at most 26 characters, because there are only 26 characters in lowercase alphabet order. So if we try to find 26 into n solution, within this 26 for loop, can we check one of the conditions? So let's say if we check this can we check this condition, each character in S occurs exactly k times. So if I have, let's say d number of unique characters in an substring, what will be the length of substring? It should be d into k, because each character occurs k times and the number of unique characters is d. So let's iterate all the values from what can be unique values of d. It can be they are 1 to 26. So I can fix this d in one for loop, and I can fix the length of this string in as d into k, and fix a sliding window of this d into k length. And then for second condition, I have to for second condition I have to check all the in first sliding window I have to check all the characters which are adjacent. For example, in this sliding window I have to check 1 2, then 2 3, and 3 4, 4 5 up to let's say f. F is the substring length, and when the sliding window moves towards right I have to remove the relation of 1 2 and add the relation of f comma f plus 1. So this is the modification in each sliding window. So this becomes a solution of 26 into n. Also there is 26 additional uh, for loop for checking frequency of each character is equal to k or not. So let's see its code and try to understand. So first as you can see I am finding all the distinct characters, unique characters in the string s. So in let's say in first example the distinct characters are 3 I, G and E. So I'm just counting those in storing in it in distinct and also initiating an answer. Now for each, let's say I am here I am iterating for the loop of D. D means all the elements all the values from 1 to distinct. Distinct just means number of unique elements in the string at the start. And what will be the window length? It will be length into k, d into k. And start, we have to start with 0, and also this round is not useful, so also I'm using a frequency map to store frequency. And set this set stores all the indices which does not satisfy this condition. So 1 2, if the absolute difference of characters between 1 2 is greater than 2, I am storing the index 2 in the set. So I will now write the for loop for this n. So window end can also be there, window start plus window length minus 1. So it just ending index of those of that window sliding window. So for loop, window start to window end and also minimum of s dot length minus 1. I am incrementing the frequency, and if I is equal to window start, I don't need to check this adjacent condition because it is equal, it is start of the window. And if the absolute difference of s of I minus s of I minus 1 is less than equal to, I will not insert it, else I will insert the I in this set. Now after initializing the current starting sliding window, I will move the sliding window one by one to its right side. Now until the window end of the window, the second pointer is less than s dot length, I will call this function have same frequency, and also there are no current elements in the set which does not satisfy. So if 1 2 does not satisfy our condition, it 2 will be present in set. So if the set is empty, there are no such indices which does not satisfy this second condition of our given problem. And if both the conditions are satisfied, I will just increment the answer, and this I will decrement the frequency of Windows starting character of sliding window and increment the pointer. And now this condition is removing the adjacent property of window start. For example, when 1 to f length sliding window moves to 2 to f plus 1, I don't need to check the adjacency property of for 2 because it will not contribute in the sliding window because its left element is out of sliding window. So I have to remove that if it is present in sliding window and the ST set. Similarly, I will increment the f last pointer, and if it is less than s dot length, I will also frequency, and if the absolute difference between both the elements is less than equal to 2, I don't have to insert it. But if they are not, I have to insert it. But also I have to check the condition. If the window size is equal to 1, it can be equal to 1 if k is also equal to 1 and the number length is also equal to 1. So for that, its left will not contribute into sliding window because the size of sliding window itself is 1. So I have to check also that condition, and have same frequency, just iterates through each frequency, and if it is not equal to a, will false, and at the end it will return true. So this window length code was available on Geeks for Geeks. So don't and I modified it by for second condition. So I guess that's it from my side. I couldn't solve fourth, but I will try from I will try to observe it later. Thank you for watching the video.